Hello, hi everybody.
Hello.
All right. Yeah, thank you guys for waiting me. And let's wait like 2 more minutes. So far, I posted 2 files under files on Canvas, and take a look over there to see if you have access, and download them first and then view it from there. One is Word doc, one is PDF. If you don't download it, it probably would be like the text would be too small to see. So if everybody have no issue to see these 2 files, let me know. One is a GD&T chart, and another one is dimensioning rules. Hello, can you guys still hear me?
Yes. Would we have to download those?
Yeah, I mean, like, just for your convenience. If you don't download it for the chart, the text might be too small to see.
Yes. Yeah, I could see both of them.
Okay, yeah, just want to make sure you guys have fully access. And this week, I'm going to talk about the basic of drawings. And next week, we're going to talk about the GD&T symbols and how to implement those into drawings. And then we're going to talk about the project requirement, because the first project, I want to focus on 2D drawing, since you guys must practice some, the 3D modeling of parts. And then the 2D drawing is just the extension of the 3D modeling of the part. And then the second project, I want to focus on the assembly, which we'll be making the engine assembly or something else. So so far, just to make sure you read through these 2 files, especially the GD&T color chart. This one, from here. Yep, this is how it looked like after it's been downloaded. It has a lot of wording, a lot of definition explained, and a lot of situations for where to apply those GD&T symbols. I guess, like, if you ever see a machine drawing, those symbols right here, like in the rectangular frame, is definitely you must be familiar with those. So this chart is just to explain when to apply those and all those different kind and different type and all that, and read through it. I will go through it thoroughly next week, but I want you guys to view it first. So next time when I talk about it, because I'm not going to go through line by line, I'm going to jump around, mainly focus on the symbols. And when I talk about it, I want you guys to have a basic idea like what I'm talking about. Okay, so sort of review this. And for the dimensioning rules, this is fairly simple, pretty much. Is way more than this, but just I summarized the sum of it for this class. And follow these rules. I'm going to talk about it just in a matter of time in this class. And for your project, I hope you can follow this and make your drawing habit in the format of best practice. And also, just try not to make mistakes, because some of these are just really common sense. And what time? Okay, we have 35 people, and I think we're good to start. So let's read through this first. So if you don't understand it, that's totally fine. because when we go through some drawings later on, like, so okay, yeah, this has been mentioned earlier. So every dimension must have associated tolerance. That tolerance must be shown clearly on the drawing. So during the first class, if you guys still remember the PowerPoint, we have a machine drawing of a flange, a very simple one. And then I specifically talked about the tolerance on each individual dimension. So either they are explicitly shown or they are summarized in default tolerance. Yeah, that's the term, default tolerance. So if you see any dimension just with one number, don't freak out. Check the default tolerance. It's definitely gonna have its own tolerance. And double dimensioning of a feature is not permitted, right? So when you're making the drawing, don't dimension any feature twice, because that's over defining, and nobody can ever follow that. Pretty much dimension with tolerance is a variation of magnitude. You're covering a range. So if you put two dimensions on it, like nobody know which one is the right one, right? Dimensions should be placed in view that most clearly describe the feature in dimension. So this is focused on the detail view. If your feature is too small, like a chamfer or fillet, you need to generate a detail view just to show the dimension on that feature. Maintain a minimum space between this object and the dimensions and between multiple dimensions. So this is just formatting. All right, don't overlap or don't put everything really crowded, and organize it, kind of like when you do a PowerPoint presentation, choose the spacing and all that. Visible gap shall be placed between the end of extension lines and the feature to which they refer. We're going to talk about that later. It's very simple. So don't have the extension line go into your model. There must be a very small gap, because if you go into the model, it can be very easy to confuse as the edge. You're going to see it just in a minute. Manufacturing method should not be specified as part of the dimension unless no other method of manufacturing is acceptable. Yeah, so we're going to talk about that too. So how do you want to machine apart and all that? And like for that dimension coverage, you should explicitly label that. Avoid placing dimensions within the boundary of a view whenever practical. So don't put any dimension inside of your view. I mean, inside of your object. It should be outside of the object, either left, right, top, or below. Dimensions for material typically manufactured to gauges or code number shall be specified by numerical values. So this explains what it does. Unless otherwise specified, angles shown in drawings are assumed to be 90 degrees. Yep. Avoid dimensioning hidden lines when possible. Edges are more visible than hidden lines. The depth and diameter of blind, counterbore, or countersunk holes may be specified in a note. Yeah, so for those small hidden features, pretty much you can just say for all counterbore is such and such, and for all countersunk holes is such depth, and you don't have to label individually. Diameter, radii, squares, counterbore, spot faces, countersinks, and depth should be specifically with appropriate symbol preceding the numerical value. Yeah, just like if you're talking about diameter, put diametric symbol in front of it. And counterbore, it has its own symbol. Those are all implemented in SolidWorks. So while making those, you just choose from the option. You don't need to download new stuff. Everything's in there. All right. Any questions so far before we go into SolidWorks? All right, nothing. Great. So this is a very simple, that's a pyramid or a stack of pancakes, and with the center hole, which is the through hole from the top to bottom. And the feature, which is just one feature, a simple revolve. And from the revolve profile, you can see it just yeah, the equal length, equal distance step from the first level. I'll go all the way up to the top. So pretty much only 2 dimension is involved with the to make this feature, since everything is equal together, equal to each other, like from here to there. Let's view it this way. So you can see the symbol mark. Sorry, the equal symbol from here. So that means this equals that equals this to equals that, and go all the way to the top. After that, revolve it from a certain distance, which is 1 inch from the axis. So this center hole has a radius of 1 inch, and diameter-wise, it's going to be 2 inches, and total is 8 inches tall. So let's open up the drawing for this one. Okay, so this drawing you see might be a little bit not formal, because this drawing is not on any format. Pretty much it's just on a blank paper. It doesn't have like those reference to area, 1, 2, 3, 4, A, B, C, D. It doesn't have that. It doesn't have title block. Doesn't have note section, or note section could be here. Pretty much it just doesn't have anything, just on a blank sheet of paper. And I have 3 views. This one is the top view, and is corresponding to a cross-section view, which is BB right here in scale 1 to 4. That's why this one is significantly bigger than that. And this is the side view, or you can call it front view. So actually, we only used 2 dimensions to make that model, right? And why it showed up so many dimensions right here. Pretty much because with that 2 dimension, we cannot have adequate information for machinists to make this part. So we, under the rule of not over defining, we need to provide sufficient information for machinists to make this part. That's why there are so many dimensions labeled, and you can see these dimensions are pretty much staggered each other. This is just to save space. You can drag them out and make them all equal out respect to the center, and this is totally up to you, but this view is going to be longer than what it used to be. So from this this view, I want to ask a question. Maybe it's just too dumb to ask. Why it only labels this dimension and that dimension, not just like all the different diameters being labeled out? Can someone tell me?
Is it because the spacing is the same? So they kind of just expect you to figure it out yourself?
Right. Anything else? So everybody think this is correct, and it's supposed to just when you hand the drawing out, it should be just like this. Anybody want to try?
Is it because those two are like the only two links that you need to know, or that like the most efficient?
Well, that's one aspect of it. Yeah. So from this point, to figure it out, the thickness of the bottom plate, yes, you just do a subtraction, or you can just label it out the thickness right here. Since everything is equal, and for this drawing, it should explicitly um, tell the machinist saying every step or every level have equal thickness and total 1, 2, 3, 4, 5, 6, total 6 places. So actually in this view is not considered complete since really nobody know they're equal, even though they look equal. And when you make those relationships are set to equal, but nobody would never know until you really write on this page. All right. And also to clean this up, what kind of recommendations do you guys have just based off your common sense? Anybody want to try?
Adding the distance for the steps could be the first step.
Yeah, exactly. So pretty much we just tell them what is distance from here to there. Really? Yeah, so this 1.33 distance, we are expecting it to be the same for every step. And depends on your parts requirement. If your parts have an overall fitment, you want to avoid this tolerance stacking up from each step. You just need to label out one dimension which that matters. For example, this exterior, this OD. You label this OD and then label one of the step and just say, you can pretty much add a note. Yeah, right here. You can pretty much write a note and just type it out like use all capital. So on drawing, if you ever trying to type everything out, use all capital. Don't ever use lowercase. So you can say each step. Each step length should be equal in total. 1, 2, 3, 4, 5. Since it's a round subject, so it's 5 places. And you put this note right under this value. What? And with this OD diameter, and you can get rid of all the diameters in between. And if this bore is very critical to you, you can leave this on there as well. So that it will be a trade-off. You have a well-controlled outer diameter and well-controlled bore, and you lost the control of each individual round surface in between. So do you guys understand what I'm talking about? Any question? Okay. Well, I hope it's not confusing too much. Well, the purpose of setting up a tolerance is you want to control certain feature, right? So let's say if this value is regulated by default tolerance, which is plus minus 30 thou. So even though it doesn't say plus minus anything, your title block, it should have a default tolerance of, plus minus 30 thou or so. So this value or this distance is really meant by could be only be 8.03 or 7.97. That's a controlled distance. So any tolerance you add on to a dimension is because you want to control the feature. Anytime you remove a dimension, that means, for example, in this case, this thickness is not labeled, right? You want to figure out the thickness, you need to do the subtraction. And why we need to do the subtraction? Because we're not leaving it as controlled. So this distance is controlled from the top surface to the top surface. And the total height is controlled by this 8. That's why that's leaving this thickness like not controlled. You have to figure it out what the thickness is after it's been made. Okay, so that's what I'm talking about. So if you're removing all the dimensions in between, you're losing the ability to control those round those diameters for those round pancakes in the drawing level. You can only know them. You can only know them after parts been made, measure them to see if they qualify or not. All right. I hope that answered your question. Yeah, I will make the drawing like from scratch for you guys. Right now, I'm just introducing the dimensioning rules and pretty much just since we just talked about this, right? I want to show you guys a real drawing and then recall your memory for like 10 minutes ago. And this is part of the stair and made by extrude, very simple. Pretty much it's just kind of like a cross section of the first object. And the drawing of this one is like this. So more dimension has been introduced. And from here, we can say, we can see there's no round subject. So no diameter or radii involved, pretty much is distance. So from here, when you have the dimensions, for example, this 2, you can Okay, you can either displace it like this. You can either place it like this or place it like that, and you can control the leader line pretty much different style right here. Yeah, so different style right here, and just make it uh make it look appropriate. So from right here, this two doesn't really look appropriate because, you know, the leader line of this arrow is in interference with the extension line of the 3. So just try to, you know, avoid any interference, and the leader line is clean, and make sure it has enough clearance of the dimension, and just place it well. You know, if I place it just like this, you guys will know this is totally a fail, right? So just a little bit formatting to show you guys, and also like when you have like a very crowded, you guys can manage whatever, like such like this, such like that, like some if you place like that, like it's gonna be a cross, and if you place like this, it will be a little bit neater. You know what I'm talking about, right? So after you place your after you annotate your drawing, spend a little bit of time to organize the dimension, and if they could be in the center, please place them in the center, because excuse me, because sometimes after this class, next class, we're gonna bring in the GDNT symbol. Those GDNT symbol either above or below the number. So if they are off center, like 5 is like this, those GDNT symbol will not look nice. It might, you may think those GDNT symbol referring to something else, you know. And also, if this is too crowded for the arrow going both outward, and make sure change the style to be like this. Don't make the two arrows overlap each other in between two extension lines. Okay, understand? All right, so this is the flange that we showed you during the first class. All right, so from here, can someone tell me what's wrong with this drawing? Like anything?
Two of the views are pretty much the same thing.
So which view is better?
The one at the bottom.
Okay. And do you think the one at the bottom is right?
Oh
think
wait,
it's
no,
a
probably the
decimal
top one. Probably the top
right?
one. Because like where's
Wait, why I changed to the top one?
wait. I'm confused now.
No worries, no worries. Just tell me your speculation. No worries.
Oh, at first I thought it was like the bottom one because of how like it has like the 4 times. It tells you, it actually tells you like the circles have the same diameter, like the same length.
Yep.
And then I switched it only because I got confused because like how the length of the arrows are apart. Like how
You mean the little
yeah
arrows
the
right there?
yeah. But then that doesn't have anything to do with it. So the bottom one would be better.
Mhm. Okay. So actually, yes, the bottom looks better, but they're both wrong. And this one is just messy. Like it pretty much used none of the correct practice. The bottom one, first, we almost never like represent a hole with 2 leader lines. I just say almost never because pretty much I've seen like thousands of drawings, and if you have a hole, most likely it will be look like that. Yeah, give me 1 second. Couldn't find the, oh, right here. It's under a different tab. Okay. Yeah, most likely gonna present like this with the horizontal text and just an arrow pointing to the hole. The two extension lines with the number in between for circular subjects, normally just ODs. So these 2 inches in diameter is okay. It's good. This 5, which is not good because we're supposed to keep all the numbers in a horizontal level, not vertically. So in order to fix that, it's supposed to be like that, either on the top or at the bottom. And for this one, 4 times 3/4 of diameter is totally appropriate. It just yeah, it just you just need to add it. So these 2 dimensions, if they replace it to this and that, that'll be totally fine. Okay. Yeah, so that's diametrical symbol. If it's radius, it's just an R.
So we're looking for, or we're looking to have the dimensions be horizontal and not vertical in all of our drawings.
Yes.
Okay.
Yep. And also like when you have the sloped leader line, make sure they display it as horizontal.
Got it. And where do we change that? Change, like, where's the setting to change it to that?
Right here. So you click on any dimension you want to modify and under leaders, and there is a custom text position. Here you can either make it parallel to your slope or horizontal.
Okay, thank you.
Yeah. And also here is different leader line styles you can play with until you find the one make you more make your drawing looks the most appropriate. And for this view right here, it's just a completely mess. We are not supposed to place any of the dimension within the subject. This is how it looks, right? And also, if you have the round feature or fillet like this and in multiple spot, pick the one with like pick the one with the arc that your arrow can point inside of, not outside of. Okay, so since like hypothetically we know these 4 rounds are in the same value, right? So if I'm making the drawing, I wouldn't pick this spot right here. I'll pick either here or here. All right, and then change the leader style and make the text horizontal, you know, etc. Making it here, nothing wrong, like technically nothing wrong. It'll just sometimes it might look a little bit confusing. So in your project, I hope you obey the rules and do the best you can. But I understand this is your first time making the drawing or the model, maybe in your life. So totally, if you make some mistake, some minor mistake, I wouldn't mind. But just don't make some major mistake like this. Place the dimension inside of the object, or this one is not only inside of the object and also is vertical. So avoid the major things. And after, because you're going to make multiple drawings on your first project, and after that, since you guys are getting groups, I hope you guys can have some peer review, for your drawings, just to see, because sometime after you made the drawing, you think, oh, it's very perfect, and you never see what's going on, like anything wrong with it, and you need a second pair of eyes to just make sure. Okay. So any question before I move on? And totally don't over define, like even though those are 4 spots and those are 4 holes, since they're identical, just label 1 and use 4x or 4 places, or just type out like total 4 holes. That's totally fine as long as you make everything clear. Okay. Any questions? Give me 1 minute. Let me grab some water. Sorry, I'm back. All right. So this one is also in the week 1's PowerPoint. It looked like a hinge or something. And it's formed by 3 features. First one is the extrude for a big L, and second one is the extrude cut to make the hole and the arc on the top. Third one, another extrude to cut the angle. And the drawing for this one, okay. So this is most likely the, I'll say the best practice of how to machine this part. So is the machine drawing of this part. All the hidden lines respect to all the hidden features. And since it's a through hole, there is a center line. And for the missing corner, identify an angle and a distance, which is enough to identify this how big of this corner is. And this edge, it will have a tolerance, and you'll see this is not plus minus anymore, even though it could be summarized with 2.5 plus minus 10 thou, but this is just another way to represent it. So under there, you can see the tolerance and precision. You can manually set it up like plus, minus, and it will show just the final value of that. So you don't have to do, the machinists don't have to do math anymore. You also can represent it like just like this with the plus minus sign. Okay, and pretty much every single thing has its own tolerance. This not the thickness of that and the diameter and radii of the top curve. And this one in parentheses, that means it's a referenced dimension. So since it's already been defined, well, one second. Yeah, I don't know what's going on with my throat. So the center point of the circle and to the bottom of the subject is defined, and with tolerance. Thank you. And the diameter of this circle is defined, and also with the radius. So pretty much, even without this diameter, like even without this one, use the radius of 1 inch and plus this 1.5 plus minus blah blah. We already have the height of the subject, which is respect to in this view is from this surface to the bottom surface. So if we put another dimension in this view or that view, it will be overdefined. But we still want to show someone about how high this object is. That's why we put a reference dimension, and the reference dimension means nothing. It really means nothing. So it doesn't hold any accountability on the drawing. You can pretend it's not there, to be honest. So either the way to represent reference dimension, either put it in parentheses, or you can just type it out after that as reference. Okay. All right. And also, oh, God dang. All right. If you're making a fabrication drawing to fabricate any part to fabricate assembly involve multiple parts, you can implement build of material. You just need to search from here. The first option, which is build of material. You have an option right here to select any view. Most likely you just select the isometric view since it doesn't have isometric here. You just select anything. Since it only involved with one part. And right here, since it only has one part in this file, there could be part only, or could be independent and could be top level. Normally, you want to select top level, so it includes everything within this assembly that is selected. But since this one only has a part, so that's why it's dimmed out. We only have part level. And after that, you just click check, and it will bring up a build of material already formatted. You can add or subtract things from here to manage the table. And since we're not going to make any fabrication drawing in this class, so this is just for knowledge. And if you want any note, you can either insert note, but this note will not be in a table format. This is just like a free note. You want to insert a table for a note, you can do a table from here. So general table, and you do how many columns, how many rows, such and such, and get the settings, and you will have a table, and you can manage it afterwards. to change the height or change the width. And normally we use tables to do note. So so type in note, and this will be your number for the callouts. And right there, you type in the content of your note. And normally it just placed on the corner, either left or right, doesn't matter. And since this sheet doesn't have format, and I will change it to have a format just for you to see what does it look like. That's kind of weird. It doesn't give me the option of the default format of SolidWorks. Yeah, just add a format which is empty. But how can I insert format? Let's try a different drawing.
But
Yes.
I think SolidWorks froze again.
Oh, it does it
Or Zoom
again?
crashed. Yeah, because when you were trying to show us about the table, like nothing, we were just seeing like the pictures, but we weren't seeing any table.
Ah, I see. Okay, let me. I'll be right back. Can you guys see it this time?
Yeah, I think so.
So can you guys see me switch to the model?
Yeah.
All right. I hope it's still recording, right? Okay, I think so. Okay. Yeah, right here under property. But anyway, like this format, the format of the sheet format is supposed to be pre-selected before you start making the drawing. And you already know, you're supposed to know which size you're going to make your part with. If your part is a giant, you can see from the preview, from size B to size C and size D, they're apparently respected different size and the width and height, such that 17 by 11 is already pretty big. The A4 size is 8.5 by 11, which is only half of the sheet. So William, this is 8.5 by 11. This is the letter size, but normally we always stick with the size B. Okay, just talking in general. At least for this class, let's stick with the size B. And if you apply the change, you see the title block showed up, and those area labels 1, 2, 3, 4, A, B, C, D, those are all there. And you can adjust the view to its appropriate position. And since these two are referenced together, and you can always break reference in under alignment and There should be a break alignment somewhere. Okay, that's kind of weird. All right, I'll figure that out later after the class. But it should be a break alignment from there, and so you can move every view freely. So that means they're not referenced to each other anymore, and you can always reconnect those alignments. Okay. So let's talk about the title block so far. So believe it or not, title block is pretty much the most important part of the drawing. Without the title block, you guys won't know what is this part, what is used for, and a lot of important information will be right here. This is the default title block, and when you're getting any company, you will have this company's unique design. Like pretty much they're gonna build their own template, and the title block will be changed like drastically. So far, let's use the solid default title block, and let's know which block we need to fill in and what you should be filling in for the project. So title, of course, which is the name of this part. And in order to make any modification, you can see like if I'm double clicking, is not letting me edit anything. You need to edit sheet format. So right click and edit sheet format, then you can start making modifications and start typing right here. So I don't know, like call it pancakes. And it's supposed to be all capital. The size B, you're not able to edit that. That go with the formatting. So you choose the size B paper, then it's the size B. Size C, then it's size C. And drawing number normally is the serial number of your drawing in your company system. So different company is different digits, normally 6 digits or 8 digits. So let's just call it 001. 6 digits, that represents as your first drawing. And each drawing should have its own unique drawing numbers. So if you label this drawing as 5 zeros and 1, then your next drawing should not be this name anymore. And rev depends on company. Some companies starts from rev 0, some companies start from rev A, but it always alphabetic, so it's A to Z. So in this case, let's just start with A. Sheet 101. Sometimes you want to deal with complicated drawing, complicated part. You need to show a lot of more views, or is a fabrication drawing, you need to show a lot of parts, and that will go, there'll be multiple pages. Something I have seen like is like 8 pages just for talking about one drawing, which is fabrication drawing of one building material. And the weight, you can get it from the mass property. All right, it's probably happened in the modeling stage. Mass properties right here, and you can read it off. The mass is this, depends on your density. So if it's iron, you probably want to put like 0.28 or something. This 0.04 is pretty small, right? And you get this from here, then you can input it here. And the scale, pay attention to the scale. The scale is talking about the sheet scale. It's not about any view scale. So if your view doesn't have a scale, then that means you're using the sheet scale. Similar to the default tolerance, if your dimension doesn't have a specified tolerance, then it goes to default tolerance, right? So any of your views is different scale other than 1 to 8, you need to label it under review. So that scale is 1 to 4, or that scale is 1 to 16 or something like that. And right here is just a blank spot. Pretty much put your company's logo or whatever on there. And comments. Normally, this will have they're gonna put something disclaimer or whatever, like proprietary and confidential stuff, like right here, or he's going to have his own cell. And for this class, I want you to fill title, drawing number, rev number, and scale, and your name and your date. You're not going to have a checker, so don't worry about it. And the approvals and all that, you're not going to have that. So we're not going to release the drawing to anywhere. So just fill out your name so I know who the author is, and your date. Also the material. You need to think of a material for a part. Anything. You can go fancy as titanium or whatever, and something expensive, or you can go just iron or stainless steel. And finish, and make up a finish that you think your part should be. Doesn't have to be like super correct. I just want to see those cells being filled, so when you making a drawing, how you're gonna fill up the title block. Okay. And right here, application. So this is pretty much kind of like an impact analysis, where it goes and where it's from. We're not dealing with those anymore. I believe SolidWorks is supposed to delete these 2 columns completely, because every company's system is supposed to have its own impact analysis, show all the way from the top level to the very detailed parts level. So don't worry about these 2 columns, okay? And the default tolerance, don't worry about it either. Normally, some company just follows the ASTM rules for detail tolerance or whatever, and that's not your responsibility. So title, part number, rev number, scale, your name, your date, material, and finish. That's all I'm asking, okay? And anything you feel necessary, you can make a note right here, like 1, 2, 3, 4, 5, and you can implement your you can cut out your note from your drawing, or the note just stating like whatever you want to say about your part. All right, am I clear? Hello, everybody. Give me some feedback in chat.
Yeah.
Thank you. This surface finish, like what kind of surface finish you want your part to have? You want it to be hard faced, you want it to be plated, you want it to be polished and all that, and galvanized and whatever, coated. Yeah, up to you. I just want to see the cell being filled. You can put some crazy stuff, but it has to be, realistically. All right. Let's see. All right, I believe this is how much I want to talk about it today. My throat is really itchy. Every time I talk, I want to cough. And I already drank too much water. So we're gonna talk more next week for GDNT, and we're gonna make the drawing from scratch as what I showed you on the first day. A completely industrial level drawing that have all the tolerance and GDNTs and all the notes and everything on there. And you guys can use that to practice. I'll say practice at least 2 or 3 times, and you should be good for a first project, even though you're making multiple drawings and I'm just making a demonstration of one drawing. So for you today, make sure you go through this GDNT chart because excuse me, next time I'm not going to go super detailed about it. I hope because this is very intuitive, just reading stuff. And this is how I learn GDNT symbols. And I believe all of you are able to read and understand the content of this sheet. So I'm not going to go through line by line and explain things, and I'll just answer questions, okay? So make sure you read through this and write down a question, and you can ask next time. All right, that's like the only homework I'll give you. Any questions? Thank you, guys. If you have no questions, you're totally free to go. And you have questions, you can stay here and ask me or email it to me. Up to you.
Professor, I just wanted to clarify. So go over that sheet and that's basically all for the homework.
Yeah, exactly.
Okay, thank you.
Yeah, just read it for fun.
Have a great week, Professor.
You too. Thank you.
Thank you, Professor. Have a good one.
You too. Okay, thank you.
Professor, do you have a general takeaway or like how much we should know by this point? Like an idea of how much we should know on this?
Okay, so you need to know how to make a part. And after tomorrow, after next week, you're supposed to know how to make a drawing. And if I gave you 3 parts, for example, like 1 plate and 2 bolts, you're supposed to know how to make those 3 parts together. And that's my expectation for so far.
Okay. All right. Thank you.
Mhm. Any more questions?